line integral. Right. So what we have discussed so far is the line integral is defined by integration over c f of x y z into ds. Right. What is this quantity actually? So we have given the surface f of x y z. This we have given. Right. We also have given the curve c. Right. How do we define this curve C? The curve C is this vector RT is equal to x of t, y of t, and z of t. Right? And how did we define ds? What is ds? ds is nothing but square root of dx square plus dy square plus dz square. Right? And the evaluation of this quantity, we represent this as f of xyz into ds by dt. Right. So what is the quantity ds by dt? This is actually derivative of x with respect to t whole square, derivative of y with respect to t whole square, derivative of z with respect to t whole square. We take the addition and then square root of this quantity. So this we have given x square plus y square equal to 1. This is the surface, right? See, I am just showing you. I hope this is properly visible on your mobile screen. Is this? Yes. Next, as we discussed, we have given the curve C also, right? So suppose we have given this curve C. The curve C is cos t, sin t, and t, right? So let me explain this curve. This is very important curve. The curve C is this. This is equal to cos t, sin t, and t. Right. This is circular helix. Circular helix. Right. It bounds by t, 0 less than or equal to t less than or equal to. Right. You can write anything here: 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Right. So what happened? The curve C looks like this. See, this is the curve. Right. So the circular helix is this, looks like this. Right. So here I drew the curve from 0 to 2 pi. 0 to 2 pi. This is the curve C. Right. So for example, suppose I am drawing the curve 0 to 3 pi, then it might be this. See, this is the curve from say 0 to 2 pi, then from 0 to 3 pi, 0 to 4 pi, 0 to 5 pi, then it is 6 pi, 7 pi, 8 pi, 9 pi, 10 pi. So it goes, so it's like a spring, right? So this is the circular helix, right? Okay. Now see, when we are saying the integral, we are using the word line integral, right? So in the line integral, we are working with this thing, integration, the portion of the function f of xy, right, into ds. ds is what? ds is very small portion of the curve C, right? So if I choose very small portion of this curve C, right, then how do we measure the length of this curve? We measure the length of the curve by this, that we already discussed earlier, right? So f of xy is the value at that particular point. We collect all such things, right, under some boundary, for example 0 to 2 pi. Are you getting my point? Right. So the sum becomes this. Now see, I am integrating this quantity. So for this particular function, here we have given the function is x square plus y square ds, right? And we are working from t equal to 0 to 2 pi. Let us evaluate this quantity. So physically, how does it look like? Right, it looks like this. See, do you visualize the portion, the pink colored shaded region? The value of this pink shaded region, right, is the line integral. See, that means suppose this is a tank and you want to paint this tank with this particular shape, then how much color you want, that quantity is the line integral. See, have you observed this thing? So this pink color shaded portion, right, that is called the line integral of f of xyz with respect to the curve. So if I change my curve, then definitely the shaded portion will be changed and the value is also changed. Right? Integration over c x minus y plus z minus 2 ds, where c is the straight line, c is the straight line segment, x is equal to t, y is equal to 1 minus t, and z is equal to 1 from the points 0, 1, 1 to 1, 0, 1. Right. How do we evaluate in the examination? So in the examination we worked with this integration over c x minus y plus z minus 2 ds is equal to integration over c x minus y plus z minus 2 into ds by dt dt. Right. Say this is equation number 1. Now we have given x is equal to t, y is equal to 1 minus t, and z is equal to 1. So what is the derivative of x with respect to t? Is 1. From this, derivative of y with respect to t is minus 1, and from this, derivative of z with respect to t is 0. Right? So what we have? ds by dt is this. This is nothing but square root of dx by dt square plus dy by dt square plus dz by dt square. Right? So this is equal to square root of dx by dt is 1 square plus dy by dt is minus 1 square plus dz by dt is 0. So plus 0 square. Right? So this is nothing but square root 2 only. Right. So let us substitute these values in equation 1. Therefore what I have, integration over c x minus y plus z minus 2 ds is equal to integration. What is x? X is t minus y is 1 minus t, plus z is 1, right? Minus 2 ds by dt is square root 2 into dt. We have to write the limit of t here, right? Now the question is, how do we find the limit of t? So choose any one coordinate. Suppose I am fixing the coordinate x. So here x is from 0 to 1, right? From these, what I can say, 0 less than or equal to x, less than or equal to 1. But what is x? X is equal to t. Therefore 0 less than or equal to t, less than or equal to 1, right? So the value of t is this, from 0 to 1. So this is equal to integration t equal to 0 to 1. This is t and t. This is 2 times t. Square root 2 is constant. Let us take it outside. This is minus minus plus. So 2 times t. This is minus 1 plus 1 will be cancelled out, and minus 2 dt, right? So again we take 2 common. So this is 2 square root 2. The integration will be t square by 2 and minus t from t equal to 0 to 1, right? Suppose we have given a surface f of xyz equal to c. Suppose we have given this surface f of xyz equal to c, then what is the gradient of f? Gradient. Gradient of f is defined by this: derivative of f with respect to x, derivative of f with respect to y, and derivative of f with respect to z. Right, this is the gradient. And as we discussed in the last semester, the gradient represents normal vector. Gradient represents normal vector. Suppose I have given f of xyz is a sphere, x square plus y square plus z square equal to 4. So this is the sphere, right? Then what is the derivative of f with respect to x? 2x, del f by del y is 2y, and del f by del z is 2z. See, this is very important concept. Try to understand the structure of this, because the magnetic theory, vector field, everything is related to this, right? So what is the gradient of f? Gradient of f is this: 2x, 2y, 2z. Now suppose I fix the point 1, 1, 1, then the gradient at point 1, 1, 1 is this: 2, 2, 2. See, this is sphere, and the blue colored vectors represent the normal vector at a particular point. So now can you feel that they are perpendicular to the surface? Can you visualize it? Are they perpendicular? Look at the axis. See, z axis. The corresponding vector, this vector, right? Look at the x axis. See, red color axis. The corresponding vector. Look at the y axis, green color. The corresponding vector. So they are perpendicular, right? So the vectors, these vectors represent the gradient of the function at particular point. So this is how the gradient of the surface looks like. What I am writing here, at point 111, this is the vector 2 comma 2 comma 2, right? At the point 100, this is the vector 2 comma 0 comma 0. So this is the vector on x-axis 2 comma 0 comma 0, right? So we have the vector on x-axis. See, પોઝિટિવ રેડ લાઈન જોતું એના ઉપર તને કે વેક્ટર દેખાય છે બ્લુ કલરનો બહાર નીકળતો એવો, that is the vector, gradient vector, right? If I evaluate at point 0 1 0, then it is 0 comma 2 comma 0. Look at the y-axis, positive green ray, right? So here we have the vector, you can see here, right? Likewise, for example, I take the point 0 0 1, then the corresponding vector is 0 comma 0 comma 2. Particular point we have different vectors, right? So infinitely many points we have actually, so there are infinitely many vectors, but in graphics we have some limitations, we cannot mention infinitely many vectors here, right? So some vectors I have tried to show in the figure. So what we have this, for some surface S, derivative of f with respect to x, with respect to y, and with respect to z, right? Now what I am doing, I am taking the dot product with dx, dy, and dz, right? For a dot product with dx, dy, dz, right? This gives me fx dx plus fy dy plus fz dz, and this is equal to derivative of f. This is vector dr. We integrate this quantity, integration of vector f into vector dr, right? This is nothing but the integration of f of xyz into ds over the curve C, right? What is the relation between this vector f and this function? This vector f is the gradient of the function f of xy z. This represents the line integral. This we know. So this is the another representation of the line integration, right? Another representation exercise related to work done. The exercises are always easy. Evaluate. Integration over C vector f into dr, where vector f is equal to 3x minus 2y, y plus 2z, and minus x square, and C is the parametric curve x is equal to t, y equal to t square, and z is equal to t cube between a 0 0 0 and b 1 1 1, right? As I told you, the exercises are very simple. Vector f into dr is equal to integration over C. What is vector f? 3x minus 2y y plus 2z and minus x square. dr is this quantity dx, dy, dz. Now just take the dot product of two vectors. So this is 3x minus 2y into dx, right? First component with first, second component with second, and third component with third, right? So plus y plus 2z into dy plus minus of x square into dz, right? Now what we have given, x is equal to t. So what is dx? Is dt. Y is equal to t square. So what is dy? Is twice t dt. Z equal to t cube. Then what is dz? Is 3t square dt, right? So if I substitute the values of x, y and z in this integral, what I am getting, 3 into t minus 2t square dx is dt plus y. What is y? T square plus 2z cube, sorry 2z, z is t cube, so 2t cube, dy is twice t dt plus minus of x square, x is t, so minus of t square into dz, dz is 3t square dt. We have to write the limit of t. Look at the point 0 0 0 to 1 1 1. Fix any one coordinate. Suppose I am fixing x coordinate. So what I have, 0 less than or equal to x less than or equal to 1. What is the parametric equation for x? X is equal to t. So I am writing x is equal to t. That is the limit of t is from 0 to 1. Right. So this is integration t equal to 0 to 1. If I take dt common, then what I have, 3t minus 2t square plus 2t cube, t square into 2t, right? Plus 2t cube into 2t is 4t raised to 4 minus 3t raised to 4 dt. Is this clear to everyone?
Yes, sir.
Yes. So this is t equal to 0 to 1. This is 3 times t minus 2t square plus 2t cube plus 4t raised to 4 minus 3t raised to 4 is plus t raised to 4 dt. So this is equal to 3 into integration of t is t square by 2. 2 integration of t square is t cube by 3. 2 into integration of t cube is t raised to 4 by 4, and this is plus t raised to 5 by 5 from t is equal to 0 to 1. Right. So you just finish this. This is 1 upon 2 because 2 upon 4. Can you tell me what is the answer? Evaluate line integral of f of x y equal to x plus y over the curve C. C is this, x square plus y square equal to 4 in the first quadrant. in the first quadrant from 20202. Line integration over C. This is equal to, right? Integration over C, f of xy is this x plus y. Now here the question is, in place of ds we are writing this thing, dx by dt square plus dy by dt square into dt. Now the question is, what is x and y in terms of parameter t? Which are the parametric equations of x and y? Can anyone tell? We have given this. X square plus y square equal to 4. So this is 2002, right? In the first quadrant. So this is our curve from 20202, right? So for this circle, the parametric equations are this: x equal to r cos theta, r is radius, so this is x is equal to twice cos t, and y is equal to twice sin t. Clear? What is t? T is the angle from 0 to pi by 2, from 0 to pi by 2, right? So if x is equal to twice cos t, what is dx by dt? Minus 2 sin t. What is dy by dt? This is 2 times cos t. So this is equal to integration over x plus y is 2 times cos t plus sin t into square root of dx by dt square. So square of this, that is 4 times sin square t plus 4 times cos square t. Sin square t plus cos square t is 1, right? So this is square root of 4. Square root of 4 is 2 dt. And what is t? T is the curve from first quadrant. So t is equal to 0 to pi by 2. So this is equal to 4 times the integration of cos t is sin t, integration of sin t is minus cos t from t is equal to 0 to pi by 2. What is the answer? Sin pi by 2 is 1, cos pi by 2 is 0, minus sin for lower limit, sin 0 is 0, cos 0 is 1, so this is equal to 8. The end of exercise. Find the work done by the field vector f is equal to x square minus y square plus x whole square and minus 2xy minus y in moving a particle in the xy plane A00 to B11 along the curve along the parabola y square equal to x. What is the formula for work done? Integration over c vector f into dr, right? So this is integration over c. Now I am write direct. Dot product of two vectors. So this is x square minus y square plus x whole square into dx plus minus 2xy minus y dy. What we have given? We have given this curve y square equal to x. So now in place of x, I shall write y square. In place of x, I shall write y square. So this is x square is y raised to 4 minus y square plus x is y square whole square. What is dx? Can I write it is 2y dy? So it is 2y dy, right? Plus, in place of x I am writing y square. So this is minus 2y square into y is y cube minus y dy. I have to write the limit of y. So observe from 0, 0 to 1, 1. So y is from 0 to 1. So this is equal to integration from y is 0 to 1. This minus y square and plus y square will be cancelled out. So what we have, y raised to 4 square is y raised to 8 into 2y. Right, so that is 2y raised to 9 minus 2y cube minus y dy. Please verify this. Is this the correct quantity? So the integration is y raised to 10 divided by 10. So finally it is y raised to 10 upon 5 minus 2y raised to 4 upon 4 minus this is y square divided by 2 from y is equal to 0 to 1. So this is what? 1 upon 5 minus 1 upon 2 minus 1 upon 2 which is minus 1. So 1 upon 5 minus 1. What is the answer? Minus 4 upon 5. I hope this is clear to everyone.